Here we're going over some factoring. We look here at the first one, and we notice it's a trinomial. So we're going to break it into two sets of parentheses. X times x makes x squared. Looks like 12 times 3. There's several different ways we can do 36, but 12 and 3 are the only numbers that can get to 9. So it would have to be a positive and a negative. That's going to multiply to be negative 36, and it's going to add together to be positive 9. Here's a little bit more complicated one. We see that the leading coefficient is a 5. So because 12 has several different factors, I'm going to do this one by factor by grouping. So I'm going to look at my first term and my last term. A times C is 60. That adds together to be negative 32. I know my two numbers have to be the same, and they both have to be negative to add to be negative. So that multiplies to be 60, and so does 2 and 30. So that's going to also add to be negative 32. Nothing else would do that. You could do negative 3 and negative 20. You could do negative 4 and negative 15 and go on, but you're not going to get negative 32 out of any of those sums. So we're going to bring down our 5w squared. That comes down. Bring over your negative 2w and your negative 30w and add the 12. So now you have this broken up into 4 terms. When you break it up into 4 terms, you can use a different process called factor by grouping. And factor by grouping is going to allow us to do w, pull out a w out of this group, bring down your sign, factor out what you can. What goes into 30 and also into 12? 6 goes into 30 and 6 goes into 12. So that's the biggest number I can pull out. 6 times 5w, that would give us negative 30w. Negative 6 times a negative 2 would give us a positive 12. Notice the parentheses are exactly the same. They have to be exactly the same. And I'm left with my w and my negative 6, and then I have my 5w minus 2. So I have factored that completely. Here we have another one. This one has an x cubed, but notice there's an x in every one of them, so we can actually pull out our GCF. So we have an x squared minus 3x minus 9. Now this is also a trinomial with a leading coefficient. Here I could multiply a times c and do the same factor by grouping. But I want to reinforce the guess and check method. I know that 2, the only way to get that is 2 times 1. The common way to get 3, or get 9, is to do 3 and 3. So if these were both 3, so 3 times 3 multiplies to be 9. This is our negative 2x squared. That would be 6 and 3. So negative 6 and positive 3. That adds to be negative 3, and that multiplies to be negative 9. Don't forget to bring down your GCF, and there you have factored it. Guess and check can be quick if you can accurately come up with your numbers. Okay, let's try that guess and check again. So we're going to use parentheses. We know that the first term has to be 5 and 1, because that multiplies to be 5. Now my last term, there's 2 different ways we could do this. We could use 2's and 3's. A 2 would give us 10. That's not very close to 30. A 3 would give us 15. That's not very close to 30. A 6 would give 6 and 1. 6 and 1 would give us 30 and 1. You see how you got to talk yourself through that. It's got to be a positive 6 and a positive 1. So you can do this without factor by grouping, but if you have trouble seeing your numbers, use factor by grouping, and that'll step you through. We'll practice that a little bit later. This is the difference of two squares. We can take the square root of the first term. You can take the square root of the second term. This gives us 10x. This gives us 5. So this is the difference of two things that are being squared. So it's the difference of two squares. So it's 10x plus 5, and it's 10x minus 5. Now at first you're really proud, you did it. But notice that you have a common factor that can still be pulled out. There's a 5 as a multiple still in there. You've got to be paying attention for that. Oh, I still have it in this one also. So 2x minus 1. So together I pulled out my 25. 5 times 5 could be pulled out from the very beginning. And I got 2x plus 1, 2x minus 1. That is the accurate factoring. Okay, you could have pulled out the 25 from the very beginning. That would have been great. But it would have been a little shorter. But if you didn't see it, this is what you get. Okay? This trinomial has a leading coefficient of 1. If it has a leading coefficient of 1, it's a lot easier for you to use the guess and check method. Because you know x times x is going to multiply together to be x squared. And when you come up with your 7 and 8, that multiplies to be 56, a positive 8 and a negative 7. You can drop those two numbers right in. You can't do that necessarily when you have that leading coefficient. Okay. So here, now this one's a little bit different also. You could treat it the same way. You could treat it the same way, but this one is a perfect square trinomial. Perfect square trinomial, you can take the square root of the first term. You just got to use your eyes. Can you take the square root of that number? Can you take the square root of the last number? Is the middle number 2 times those two multiplied together? And that's 15. 15 times 2 is 30. 30t. And that middle term is that. It's 30t. So yes, this is a perfect square. Yes, it's a perfect square. And yes, the middle is 2 times those two numbers multiplied together. If you have that, then you have 5t plus 3. And actually, this is going to be a minus because the 30 up here is a negative. So that, in fact, has to be a negative. And it's a perfect square. It's going to be 5t minus 3 times 5t minus 3. So we can use a square there. We look at this one, looks a little complicated, but if you notice, they're all even numbers. So I can pull a 2 out in front. That's going to leave me with a 3r squared, a 19r, and a 20. So I pulled out my GCF first. And then I can use a guess and check method, because 3r times r, that would give me a 3r squared. Now I need to come up with two numbers that multiply to be 20. Well, that could be 2 and 10, that could be 5 and 4, but what's going to get me to 19? Well, some people are going to jump the gun and say 20 and 1. Because 20 and 1 multiply to be 20 and add to be 19. You have a minus sign, but you can't have a minus sign. Otherwise, your multiplication would be negative. So 3 times 5, it looks like 5 and 4, because that would be 15, a positive 15, and a positive 4. That makes 19. Now, if this guess and check is a little confusing to you, and it has that leading coefficient, I'll do the factor by grouping again. Okay. We can do factor by grouping. Some people like to make a big X. I like to make a sum and product table. So the 3 and the negative 8, that multiplies to be negative 24. The 10 is what we're adding to become. So we know the two numbers have to be different signs, and the larger number has to be positive because they're adding to be positive. So negative 1 and negative 3 and 8, well, sorry, negative 1 and 24. Negative 2 and 12. There it is. That adds to be 10. So I'm going to bring down my 3x squared, bring over my negative 2, put an x next to that, bring over my 12, put an x next to that, and bring down the negative 8. Notice how the 3x squared and the negative 8 are still part of the problem, and the middle part adds to be 10. So I'm going to circle my two groups, factor out my x. That leaves me with the 3x minus 2. Bring down my sign, factor out what you can. That looks like a 4. 4 times 3 and 4 times 2, and that has to be a negative 2. What's inside the parentheses are exactly the same. So I have my x plus 4. And I have my 3x minus 2. It'll always take you 3 steps for factor by grouping. This one looks a little complicated, but if you notice, it's divisible by 3, and they both have a p in it, so that's going to leave me with 6p minus 1, and there's nothing else to factor out. We're done. We factored it completely. This one here is the difference of two squares. This has a GCF also. And that'll help you see that difference of two squares. If you pull out that GCF, now we have q squared minus 4. You can take the square root of both of those terms. If you can take the square root of both of those terms, then it's q minus 2 and q plus 2. You can switch the plus and minus. It could be on either one. It doesn't matter. All right, this one. Well, this one looks familiar to that perfect square trinomial, but I also notice that 4 goes into every one of these numbers. So if I pull out the 4, 4 times 1 makes 4. 4 times 12 makes 48. And 4 times 36 makes 144. So this is going to become 4 times z minus 6 squared, because this is a perfect square, that is a perfect square, so you get z and 6, and the middle is 2 times that amount. We notice over here the number 13 has a GCF. And from that, we can break it apart into our two factors. What multiplies to be 5 and adds to be 6. We factored it completely. Here we have an x in every term, so we can pull that x out. That leaves us with 4x squared plus 5x minus 6. Okay, now this is a little trickier guess and check because there are multiple ways to get 4, there are multiple ways to get 6. You can make some mistakes here. So maybe it'll be best for you to use the factor by grouping. Negative 24, that adds to be 5. That's going to be negative 3 and 8. That multiplies to be negative 24, that adds to be 5. So we're going to say 4x squared minus 3x plus 8x minus 6. Bring down my x. Now I'm going to factor out what I can out of each one of those. Looks like I can bring out an x, and that's going to leave me with a 4x minus 3. And I'm going to factor out a 2. That leaves me with 4x minus 3. So parentheses are exactly the same. So I bring down my x, and I bring down my 2, and I have my 4x minus 3. Don't forget that you had that original GCF that needs to come down. Now this is the first one that we've had all 4 terms. When you have 4 terms, that happens to be just a factor by grouping. So this is one reason why we want to learn about factor by grouping. That's pretty much the only method that we have for this. It has 4 terms. This is a cubic question. There's nothing to factor, there's no GCF we can pull out of this. So I look in here and I see that there's an m squared. That would leave me with a 3m in the first spot and a negative 1 in the second. I have to be able to distribute this back in. Bring down your plus. Pull out your GCF out of this group, and that would leave us with a 3m and a minus 1. 3 times 3 is 9. 3 times negative 1 is negative 3. You need to be sure you produce the same thing. So you have m squared plus 3 and 3m minus 1. Neither of those can be factored anymore. So that's as far as you can go. Now we're looking at one with an x to the 4th power. But the key thing here is that this is also an x squared. It's half the amount. We don't have special rules for factoring to the 4th power, so we're actually treating this, since it's half the power for the first term and the second term, we're going to treat this as a quadratic. This is x squared and x squared. When you multiply those, you add the exponents to get x to the 4th. Now, because it's a leading coefficient of 1, we're looking for 2 numbers that multiply to be 24 and add to be 10. That looks like that would be 6 and 4. So they would both have to be positive for you to multiply to be a positive and add to be a positive. Neither of these can be factored. There is no factoring the sum of 2 squares. So this does not factor apart to be x plus 2, x plus 2. Here's our first difference of 2 cubes. The difference of 2 cubes has a rule. If you do a term cubed minus another term cubed, you can take the cubed root of both of those terms, square the first term, multiply the 2 together, and don't forget to change the sign, and then square the last term. That's exactly how we could factor this. So we'll take the cubed root of w cubed. We'll take the cubed root of 27. This is not w minus 3 cubed. Many people make that mistake. You've got to square the first term, multiply the 2 together, and change the sign, and square the second term. And that is the difference of 2 cubes. Here's to the 4 terms again. So we're going to look at it by factor by grouping. We can factor out an x squared. That would leave us an x minus a 3. Bring down your plus. Factor out what you can, which is a 16. That would leave us an x minus a 3. Bring down your 2 terms. X squared plus 16. X minus 3. This is not factorable. This is not x plus 4x minus 4, because it's not a minus 16, and it's not even x plus 4x plus 4. You can you can check into the next video for the other side.